Hello, dear friends. Good afternoon. So, hi. My topic is optical illusion. So, I'm gonna do my best and present it to you. But before I start, I did my research on that topic, but unfortunately, I couldn't find a lot of information. In our calculus book, there was an article mentioned, but I couldn't find that article. So, let's start. Uh, okay. Optical illusions can be can use colors, lights to create images that can be deceptive or misleading to our brain. I'm not sure that it is related to my topic, but if you look at these two pictures, there is optical, like this illusion pictures. If you, for example, in the first one, try to count how many legs it can be, not as easy, not as easy as it may look. And in the same similar thing in the second one, it's hard to find the black dot here because whenever you focus, that black dot seems to disappear and appear in somewhere else. If you take a more calculus perspective, it says that optical illusions, a tangent line or secant lines to a family of curves. So to find where the bending occurs, the illusion occurs, we must find the first derivative, and this bending occurs at the tangent point where the lines intersect a family of lines or curves. So if you look at these pictures, there is an illusion created by having line intersect a family of curves. In each case, for example, here the lines appear to be curved. So like here, here, and here. So now let's try to solve this simple derivatives. So I gotta proceed to my professional illustrator. The first thing, I'm going to substitute the value of c into the given equation and solve for y. So here what I got, we get that y, if we solve for y, is equal to this value, and the derivative is equal to this value at the given point is equal to 3 over 4. I'm not sure should I explain how I solve because I think it's simple. Yes, and the picture to this is a circle with a family of curves and lines which seems to be curved. Okay, the second one is hyperbola. Again, we still solve this like this. Substitute c, solve for y. We get 4 over x. The derivative of 4 over x equals, we will rewrite it in the form of, okay, we will rewrite it in the form of 4x minus 1. And when we do when we find the derivative, this minus 1 comes here. It will come here and it will be 1 minus 1 minus 1. It will be minus 2. And then if we rewrite it, it will be in this form, minus 4 over x squared. Then we substitute x and we get minus 4. So yeah, that's minus 4. And here's another optical illusion where the lines seems to be curved. This problem number C is lines here, family of lines, and solving this equation and finding the derivative. So solve for y equals ax over b. The derivative of this value, we can think of a and b as being a constant, so x disappears, and when we substitute a and b values, we get that it's equals to square root of 3. And the last and final problem is D, cosine curves. So I'm sorry. Here's it, cosine curves. Solve for y, substitute c. The derivative of cosine is minus sine, therefore then it becomes negative. The sine of 60 degrees, pi over 3 is 60. is equal square root over 3 divided by 2, like 2 and 2 disappears. Ah, gosh. Okay, let me write it. We have minus 3 multiplied by square root of 3 divided by 2. Okay, what else? And then square root of 3 over 3 is our final answer to this equation, to that problem. I'm pretty sure it's a very interesting topic which I couldn't fully uncover because lack of information. And also I will sum up with a real world application. Optical illusions are almost used in every aspect of our life, such as fashion, architecture, like this, wait a minute, like this, architecture, and aviation schools. Yeah, I guess that's it. Thank you for attention for such, yeah, that's issues.